I'm going to walk you through number 1 here on 6.4, homework number 1. So you'll notice that we had 2 p primes here, so I just switched this one to just be p, so don't worry about the prime here. Now, the first question we have is, what's the equation for the line of reflection that points p and p prime? So my first step here is I'm going to draw a line between these two. Now, the slope of my line here equals -1/1, or -1, however you want to approach it. So, in order to get the line of reflection, what I need is a line that is perpendicular to this. So I do know that slopes that are opposite reciprocals are perpendicular. So I'm just going to flip this over and make it the opposite. So the opposite of negative is positive. So I'm looking at a slope of now of +1 for my new line. So I'm going to go right here from the midpoint of my line here that connects both of these points. I'm going to go from the midpoint. I'm going to go up 1, over 1, up 1, over 1. I'm going to keep doing that. And I've got myself my line of reflection. I'm asked to write the equation for it. Now I'm noticing that y equals, now I know my slope is 1. You don't necessarily have to write the 1. I am though. Whoops, I didn't want to put m, I wanted to put x. My y-intercept is 1, 2, 3, 4, 5. X plus 5. Nice and easy. Now they're asking, what is the equation for the line of reflection that reflects points p prime and p2? So, I'm going to do this in green. I'm going to get a lot of lines going on here. Try not to get too lost. What I might even do, now that I've done this, I'm going to get rid of it. To make it a little easier, right? So we don't have as much to wade through. Alright, so now I'm just going to deal with P1 and P2. So, I'm going to draw my line. In this case, I'm going to look at the line that I've just connected here, and I know my slope is -3/1. I'm going to identify my midpoint right here. Now, to make a perpendicular line that goes through it, which would be my line of reflection, I need, once again, a line that's the opposite reciprocal. So I can slide it over here, flip it over, and the opposite of negative is positive. So now I want a line with a slope of 1/3. So I'm going to go up 1/3, make a point, 1/3, make a point, and I can make a nice line here. It's not going to go perfect over here, but here we go. Now I got my line of reflection. Okay. I've got my line of reflection now. Now I have to write an equation for it. This is going to be a little tricky, so hang in there. A lot of you might be inclined to just try and estimate what you see here. I wouldn't recommend that. Whoops. Now here's the key here, right? You want to start out with your equation of y equals mx plus b. Slope-intercept form gives us a line, right? Typically, we're really used to filling in our slope and our y-intercept. However, in this case, we don't really have a great y-intercept. However, I do know my slope. So, I can plug in my slope, which is 1/3. And now I can replace x and y to get b. Now the thing is, I can use literally any point on my line here. The line I just created here. I'm going to go with, let's see, I'm going to go with this one. It doesn't matter which one. I could have used this one or this one. But I'm going to go with this point here. The reason is my coordinates are, let's see, -1, 0. What that allows me to do here is I can plug in 0 for my y and then -1 for my x. Now I'm just solving for b. Here's the reason I like this. Let's do it out. I'm going to have to slop over down here, so don't mind that. I get -1/3 plus b. To get b alone, I'm going to add 1/3 to each side. And look what happens. I get +1/3 equals b. So now I can create a slope-intercept form equation because I have my slope, 1/3, and I have my y-intercept now of 1/3. I wouldn't have been able to get that just looking here. So if you get a case like this where you have a y-intercept that isn't immediately easy to pick up, all you got to do is just plug in a point on the line plus your slope, and you can get your y-intercept just like I did here. So I'm going to shrink this down. And as you're going to see, we're going to do a bit more here. So I'm going to get rid of this. And last, but by no means least, I'm going to be doing the last part here, which is about lines of rotation for 180 degrees. It says P2 can be considered a 180-degree rotation of P. So again, I'm establishing this as P. Now, if it's 180 degrees, think about things that you know are 180 degrees. You might be thinking of, well, I know all the angles of a triangle equal 180 degrees, but also a straight line gives you 180 degrees. So all I have to do is draw a line between the 2 points, P2 and P1 here, and then to find the center, all I have to do is find my midpoint on this line, which is right here. So the center of this rotation would be -3, -2. And that's the easy thing here. When you're trying to find point of rotation for a 180-degree turn, literally all you have to do is draw a line and then find the midpoint. That's it. It's nice and easy. But anyways, I hope that helps you out with number 1. Best of luck with the other examples. And if you need help, I'm going to be posting some more examples for more videos, for the other examples. Good luck.